Hello, welcome to class. In today's lesson, we'll be learning chemical bond. But before we proceed, let us quickly define these terminologies. Number one is electronegativity. Electronegativity is the ability of an atom to attract electrons to itself when found in a chemical combination or chemical bonding. And all non-metallic elements are electronegative. We said non-metallic elements are electronegative. Which means they have the ability to attract electrons to themselves, and when they do so, they form negative ions. They form negative ions. Now let's quickly define the next electropositivity. Electropositivity is the tendency of an atom to freely give out its valence electron during chemical combination. All metallic elements are electropositive. And when they give out their atomos electrons or the valence electrons, they form positive ions. Now, what are ions? Ions. We can say, okay, ion or ions. An ion is an atom or group of atoms that possesses electric charge. So it's an atom or group. Atom or atoms. Yes. It could be more than one atom that possesses electric charge. This electric charge could be positive or negative. Let's look at some examples of ions. Atoms and ions. Let's look at the first element, hydrogen atom. We are using the symbol here. The ion it forms is H plus. Because hydrogen is a group 1 element, it has a valency of 1. Hydrogen is not a metal though, but because it has a valency of 1, it's grouped among group 1 elements. So when it finds itself in a chemical combination, we want to form a chemical bond with a more electronegative element, it will willingly give out its atomos electron, forming positive ion. Let's look at sodium. That forms sodium ion. Now we also look at zinc. It forms zinc ion. The ion they form is the number of charge they have. Like this is one positive sign, one positive sign, two positive sign. Is because of the number of valence electrons they have. Now let's look at chlorine that form chloride ion. and oxygen with a valency of 2 that will form oxygen ion, because chlorine, we have a negative ion because it's an electronegative element that attracts electrons to itself. So during chemical bonding, chlorine will attract one electron to itself because it has in its valence shell, it already has 7 electrons. So it will attract one electron to itself, forming a negative ion. While oxygen in its valence shell, it has 6 electrons. So it will attract 2 extra electrons to itself to reach the octet configuration. So it will form oxygen ion, which is what we're seeing on the board. Now let's proceed to today's lesson. First, what is chemical bond? Say a chemical bond is the attraction between atoms, ions, and molecules to form a chemical compound. That attraction that exists between 2 atoms in a compound is what we call chemical bond. Now the question is, why will elements undergo chemical bond, chemical combination? Why would they want to form chemical bond with other elements? Because they want to attain stability. Stability. Who doesn't want to be stable? Recall in our previous lesson that we said we have 2 types of stable configuration: the duplets and the octets. The duplet being where the valence shell, the outermost shell, has maximum of 2 electrons, and the octet configuration is when the outermost shell, what we call valence shell, has maximum of 8 electrons. Now, the group 8 elements, which are the noble gases, do not undergo chemical combination because each of them has achieved this stable configuration, with helium, the first member, having 2 electrons in its outermost shell, and other members of the group have 8 electrons in their outermost shell. Now let's look at types of chemical bonds. Types of chemical bond. The number one we're looking at today is what we call ionic or electrovalent bond. The second is covalent bond. Then we'll be looking at metallic bond. Now let's quickly take the first one, the ionic bond. What forms ionic bond? This bond is formed when a metallic element freely gives out its outermost electron or electrons to a non-metallic element. They do that because we say they are electropositive. They have that ability, the tendency to give out their outermost electron to attain what? Stability. And the non-metals will accept those electrons because they are electropositive, so they have the ability also to accept electrons when they undergo chemical combination, also to attain stability. So let's look at an example of an ionic bond. We consider the formation of sodium chloride. With a chemical symbol NaCl. This is sodium with atomic number 11, which means it has 11 protons, which are positive charged particles, and 11 electrons, which are negative charged particles. Atomic number is simply the number of protons in the nucleus of an atom. And for an atom to be electrically neutral, it must have equal number of protons and electrons for it to be neutral, because protons are positively charged and electrons are negatively charged. Now, if we write the electronic configuration of sodium, the first shell, remember the K, L, M, N, O, P, Q shells, the 7 shells, which represent the 7 energy levels. So the first shell takes maximum of 2 electrons, while these other ones take 8. So the first shell will take 2. We are trying to fill these 11 electrons that sodium has into the shells. Remaining 9, the second shell will take 8, then the last shell will take 1. Reacting with chlorine, that's atomic number 17, which has 17 protons and 17 electrons. Positive, negatively charged. Each electronic configuration will be 2, 8, that is 10, 17 minus 10. The last shell will have 7. Now let's draw these shells identifying or indicating these electrons. The first shell for sodium will be 2 electrons. The second shell, 8. And the last shell, 1 electron. Now for chlorine, the first shell, 2 electrons. The second, 8. While the last, 7. 7. Now what happens here is that sodium, being an electropositive element, willingly transfer these electrons, this valence electron, to chlorine, forming sodium ion. So here we now have sodium. Because a shell is a region where we find electrons, and since sodium has transferred this electron, it has complete transfer to chlorine, so this shell will cease to exist. So it will now have just 2 shells. The first shell with 2 electrons and the second shell with 8 electrons. And that is sodium ion. Is ion is a positive ion because it now has excess of one proton. Remember, formerly it has 11 protons and 11 electrons, but now it has lost one electron, so it now has 11 protons and 10 electrons. So it's like plus 11 minus 10, giving us plus 1. Alright, when writing the ion, we're not going to write sodium 1 plus. No, we don't put 1 in chemistry, so it's simply going to be sodium plus. Now going to have the chloride ion, which now has, still have this first shell, the second shell with 8 electrons, and the third shell now with 8 electrons. That is now chloride ion with 17 protons and 18 electrons. So it's like plus 17 minus 18, giving us minus 1. So we don't write 1 in chemistry. That's why this ion is just 1. Now the electronic structure they have achieved now here is sodium now has the first shell 2 8, while chloride ion now has 2 8 8. You see that each of them have attained an octet configuration. I mean, their valence shell have attained an octet configuration. So if we write the chemical equation to show this reaction, it will be sodium reacted with chlorine to form sodium chloride. Sodium chloride is an ionic compound which possesses ions, conducts electricity, and conducts heat. They are electrolytes in aqueous solution, and they have high melting and boiling points. Let me add this bonus. We can now write the ionic equation for this reaction to be the sodium lost an electron to form sodium ion, while chlorine gained an electron to form chloride ion. We have come to the end of today's lesson. If you found the lesson interesting, if you got value, don't forget to share my videos, like so YouTube will recommend to other viewers. Subscribe to my channel if you have not, and please stick to this channel as I will be uploading another value-packed video. Till then, remember, you are my superstars. Bye for now.